Good morning, ladies and gentlemen. So today, you're so excited because we're doing angle proofs. Yay! Now, this will be just like it was for the segment proofs, but it will be easier. You've seen it before, and I think angles are a little easier to see. So the first thing we're going to do is go through our theorems and definitions just to make sure that we have a good tool chest. So instead of writing them down, let's review them, then we'll pause the tape and you can write it down. So yesterday we had vertical angles theorems. They were two angles whose side rays made opposite pairs, so they made two straight lines. And we showed yesterday that if they were vertical angles, then the angles were congruent. Now, if you're stuck in a proof and you don't know what the name of it is, you can write that out. Or you could do the shortcut, because remember, mathematicians are lazy, and the name of that is the vertical angles theorem. We also said if two angles were linear pairs, well then they made a line, and that meant that their angles added up to 180 degrees. So that would be if two angles are linear pairs, then the angles are supplementary, and the name of that is the linear pair postulate. It's a postulate because we can see that it's true. No one needed to tell us that. The next one says if two angles are supplementary, now remember they do not have to be a linear pair, then their angles add up to 180 degrees. That's just the definition of what supplementary angles are. So we can just write def of supplementary angles. And then we said if two lines, well this is a new one actually, if two lines are perpendicular, then they intersect to form right angles. That's why we did the little squares in the corner. That's called the definition of perpendicular lines. Now be careful, the definition of perpendicular lines isn't that they made 90 degrees. It was two lines that made right angles. So that means if you have two lines that have a little square on it, you're going to start with the definition of perpendicular lines, which is they intersect to form right angles, and then you're going to go right into the definition of a right angle, which is if the angle is a right angle, then it measures 90 degrees. You can't jump from two lines are perpendicular to they measure 90 degrees. You have to put those two together, so just lock that into your brain. Definition of perpendicular lines goes first, and then the definition of a right angle to get to your 90 degrees. And then the last one that we have, which is very useful, is if two angles are right angles, then they're congruent. And I know you're saying, well, duh, but remember, we're not saying they're 90 degrees, we're just saying they're right angles, then we know they're 90 degrees, therefore they've got to be congruent. Okay, so rather than doing all those steps, we can use the right angle congruence theorem. Alright, so we're going to start with one proof, we're going to do it together, and we'll kind of see how these step out. Let's start with a algebraic proof. Alright, if you haven't already, we're going to stop the tape so we can copy those down to make sure that we have that. When you're ready, we'll turn it back on and we'll try this proof. Alright, so here's what we've been given. We've been given that measure of angle AED is 2x plus 10. So the first thing you're going to do is you're going to mark it, right? So we know that it's 2x plus 10. We also know the measure of angle BEC is 2y minus 4. So we know because they're vertical angles, we can mark them the same. The bummer is this is an x, this is a y, that's not going to work. So what else did they give us? The measure of angle DEC is 3x minus 5, so we mark that. Okay, what we're trying to prove is x is 35 degrees and y is 42 degrees. So before we start, let's just see what we know. We already said these guys are vertical angles and they're congruent, but that doesn't help me find x or y. So what else have we got? We have these two right here. Now, if we cover up this section right here, and we look at just this portion, we can see that angle AED and angle DEC make a linear pair. And they're both x's. So we can add those up, set them equal to 180, find x, and then voila, we can substitute in here, go back and forth, and that is exactly what we're going to do. So first we just need to start with what they've given. We write down whatever they've given us, this big long stuff, and the reason here is given. All right. Now we're going to write in there exactly what we said. So first we're going to say that angle AED and angle DEC are supplementary. Now we could have started with they are linear pairs, but remember we have the linear pair postulate, which says if they're linear pairs, then they're supplementary. We can skip that step and just use the linear pair postulate. All right, and then from there, well, supplementary, right? Use our breadcrumbs. What do we know about supplementary angles? Oh, they add up to 180 degrees. So the measure of angle AED plus the measure of angle DEC is equal to 180 degrees. And how do we know that? The definition of supplementary angles. Okay, at this point, we're ready to jump into our algebra, right? Here's where we're just going to do our substitution. Okay, so we know the measure of angle AED is 2x plus 10, plus the measure of angle DEC, which is 3x minus 5, equals to 180 degrees. All right, now we're going to use our algebra, right? We're going to combine like terms. And since we're doing it for both the x's and the numbers, we can do it on the same line. And we can say, simplify, or combine like term. Either one is fine. Okay, we're going to subtract 5 from both sides to get 175. Subtracting from both sides is the subtraction property of equality. We're going to divide both sides by 5. So that would be our division property of equality. And now we have that x is equal to 35, which is fantastic. But they also want y. So what did we say? Oh yeah, these guys are vertical angles. Oh, okay, well we got to say that, right? So we can say angle AED is congruent to angle BEC. We cannot say their measures are equal yet, because what we have is that vertical angles are what? Congruent. So you can either write vertical angles are congruent, which is my favorite, or you can write the vertical angles theorem. Then we can jump into the measures are equal, and remember, just like we did with the segments, if the angles are congruent, then the measures are equal, and that would be the definition of congruent angles. From here, we're just going to jump into, now what's the next one? Substitution. And I'm going to be quiet, and you guys are going to finish this up. And when we're done, we have something that looks like this. So here it is typed out, because I know my writing is not so fantastic. So we'll pause here again, finish writing down any of the ones that you don't have, and then we're going to move on to the next one. All right, on the next page we just have some tips here, right? When we're working with proofs, rarely do we ever use congruence. Usually we're going to start with congruence. We're going to transfer it over to measures so we can add and subtract stuff together. Remember, we can't add and subtract things, only measurements. Okay, if we only are given angles and nothing else, then we're going to use the angle addition postulate. We can't set things equal unless we have that word bisector. So you're always generally going to use the angle addition property, and when you do that, you'll probably use the subtraction property of equality somewhere to figure out how things are equal. The other one that's very common is using the addition property, adding the same angle to both sides of the equation to equal up what you're looking for. And remember, if they use the word bisector, then you know you are definitely going to use the angle of definition of angle bisector, so you can set those angles congruent to each other. All right, let's take a look at one that isn't algebra based. Now we're only going to do the substitution with the numbers. But you're going to find with angles it's a little easier because it makes a little more sense rather than letters, because I think we're used to understanding now that these are measurements. So we're starting with angle 1 and angle 2 are complementary. So let's just mark the stuff we know. Well, if they're complementary, then that's 90 degrees, and we can mark that up like this, right? And we're given that angle 1 is congruent to angle 3, so we can mark that. And we're given that angle 2 is congruent to angle 4. And what we're trying to prove is that angle 3 and angle 4 are complementary. Now remember, we're looking at this and we're like, well, yeah, of course, we can see that, but you have to prove it. So let's look at the steps that they have. They're giving us that angle 1 and angle 2 are complementary because it's given. And then they jump to write what we did. the measure of angle 1 plus the measure of angle 2 is 90 degrees. Why did we mark that? Well, you're saying, well, because that's what it means to be complementary. Right. That's what it means. So it is the definition of complementary angles. All right, and then we did angle 1 is congruent to angle 3, angle 2 is congruent 4. We could have done that on the first line, but we're kind of making a flow here, and so that was our given again. Why did we do that? Well, we got to remember, if we're going to add stuff like we are up here, we're going to have to do some substitution, which means we can't use congruent. We're going to have to move right to if they're congruent, then the measures are equal, which is the definition of congruent angles. Make sure you're writing angles here. These are not segments. All right, let's see what they did then. Then they said the measure of angle 3 plus the measure of angle 2 is 90 degrees. Whoa, where did that come from? All right, let's look back up here. This says the measure of angle 1 and the measure of angle 2 is 90. Ah, they took out this and popped in this because we just said right here that the measure of angle 1 and the measure of angle 3 are congruent, so we can substitute those out. So this is our substitution. And then check it out. We're almost there. This is 3 plus 2. We want 3 plus 4. Aha. Now check it out. Now we can pop out this measure of angle 2, and we can substitute it in here because we know that the measure of angle 2 is equal to the measure of angle 4, so we can pop out this and pop in here, and that is by substitution. Now be careful, we are not done. What they want, we have to have exactly what they said, and they said prove they're complementary, and you're like, yeah, well we did, but we didn't say that. So we'd have to write the measure of angle 3 and the measure of angle 4 are complementary because, well that's what we just showed, Mrs. Woolley. Right, that's what we just showed. Definition of complementary angles. And here it is in a much prettier format. All right, at this point in time, we're going to stop the tape in general because we're going to have two other tapes to go to. We have the CP version of the notes and we have the honors versions of the notes. So this will conclude the general section of the notes.